Good afternoon or good evening, maybe even good morning, depending on where you are. I am Eric Schumacher Rasmussen. I'm the editor-in-chief and VP of Streaming Media and the conference chair for Streaming Media West. Thanks for joining us for this Innovation Hour. We're presenting one of these each day, a chance for leading solutions providers in our industry to give deep dives into the solutions they offer, and along the way, shed some light on solving some of the industry's most vexing problems. So once again, thanks for joining us. Like I've said each time this week, before every other virtual streaming media event, I would say, and we'll see you next time in person. I'm not going to say that this time, but Streaming Media East is set for May 24th and 25th in Boston. So we hope to see you there in person. And we will have one more Streaming Media Connect virtual event between now and then, and that will be coming up in February. And it will be cleverly titled Streaming Media Connect February. Surprised, aren't you? A few housekeeping notes before we jump in. We will be seeing 3 presentations today. If you have questions for our presenters, please put them in the Q&A rather than in the chat. That just makes it easier for the presenters and I to keep track of those questions as they come in. Also, live transcripts are enabled. So if you see live transcripts running across the bottom of your screen and you want to shut them off, go to live transcript at the bottom of your Zoom window and click disable transcript or disable subtitles. I forget what the exact verbiage is. Last but not least, if you are here, you are automatically entered into a drawing for a $50 Amazon gift card. We'll draw the winner at the end, though, and you must be present to win. So stick around and see if we pick you. I'd like to thank our diamond sponsors who are sponsoring the entire week's worth of presentations and panels and keynotes. That's Limelight Networks, Conviva, Signient, and Video Guys. And we have video messages from them right now.
VideoGuys.com is your source for the LiveView Solo, and our Black Friday special starts now.
Stream from anywhere, anytime with the LiveView Solo and Solo Connect bundle. Buy now with the 2 or 3 modem kit and get 1 month Solo Connect free. This includes unlimited data and LRT Cloud and is only available until November 30th, 2021.
Go to VideoGuys.com or call us at 800-323-2325 to take advantage of LiveView's Black Friday special today.
In this era of streaming video, we are pioneers, helping make your stories more vibrant. Conviva lives in billions of apps on devices all over the world, measuring trillions of data points each day to provide real-time insights for your content, ads, and social. Conviva. Every stream, every screen, every second.
Today, we're going to be hearing presentations from Bitmovin, Nanocosmos, and NETINT. And let's kick things off with Katy Oberdiek and Andy Francis from Bitmovin. They're going to join us and talk about encoding innovations for maximum quality. Katy, welcome. Andy, hello.
Hi. Hi, Eric.
I will pass it right on over to you.
All right. Can you please let me know if you see my presentation?
Yes, I can, and yes, we can.
All right, wonderful. Thank you for the introduction. Yes, my name is Katy. I'm the Senior Product Marketing Manager here at Bitmovin. And quickly to introduce also Bitmovin. Bitmovin is a leading global provider of video software and cloud infrastructure for all companies streaming video. So our cloud-native solutions ensure the most flexible and scalable media encoding, playback, and analytics solutions available. And we help customers to optimize their content globally using future-proof codecs on the largest number of devices and screens on the market today. So now to our presentation. As the title already gives it away, we will focus on encoding innovations. And this simple image here shows the main challenge for any encoding solution. And that is finding the sweet spot between taking assets quickly to market and delivering the highest quality at the same time. So there are often trade-offs in finding that sweet spot for your product and your business. And our presentation today consists of two parts. The first part focuses on innovations that you can already find in the Bitmovin product and in the market. And the second part will present innovations that are more experimental and are being tested with selected customers. So you already saw the scale on one of the first slides, and with the quality goal on the one side. So the quality of experience for video viewing is very, very critical at this point for today's brands, because they're trying to make the most out of their content. And that's why, as the 4K TV market, which is expected actually to reach over $380 billion by 2025, that's why many streaming providers are looking to stream their video content in 4K, HDR, and Dolby Vision. So the problem is that many brands find it very cost expensive to create and deliver high quality video content. And in addition, higher quality video formats require technology beyond the status quo. We want to start by looking at the video landscape, video codec landscape, sorry. And so because the adoption of newer codecs, that's often like guarantees the biggest leap in quality improvement. And we're opening here with some results of our upcoming Bitmovin video developer report. For the fifth time, we asked the video developer community which video codecs they are currently using, among other questions, obviously. But so I think they're obviously like the usual suspects leading the pack, but we wanted to take a closer look today at AV1 and VVC. VVC was actually an option for the first time in our survey, and we suspect that some of the answers include also companies that are just testing VVC as this new efficient codec. AV1, however, has been on the list for several years. And you can see the adoption rate over the past 4 years. So Bitmovin actually released AV1 support 2 years ago, but it seemed like the rest of the ecosystem wasn't really ready for that yet. It's a little bit different today. So with the adoption by other consumer platforms, oops, went too fast. So with the adoption by other consumer platforms, we really expect now a big jump in adoption for AV1. As you can see here, YouTube is using it extensively for their most popular videos. Amazon just announced that the new Fire Stick 4K Max has AV1 decode support. And with this, I'd like to hand it over to Andy to give us a few more insights into AV1 and VVC.
Thanks, Katy. So as you mentioned, AV1 is not really something new for us here at Bitmovin, but we did want to bring it up today for a couple of reasons. First, as you mentioned, just to highlight that in our industry, and especially with codecs, there is usually a lag between when a new innovation is technically available to use and when the rest of the ecosystem and market is ready to support it. The good news is that we do see AV1 support is finally reaching a critical mass with relatively cheap consumer hardware devices offering decode support, and platforms like YouTube taking advantage of the data savings and total cost of ownership reductions. Also, AV1 encoding speeds are now almost on par with HEVC and still improving. So that had been one of the barriers to adoption previously, but now we really do see a big opportunity around using AV1 to deliver 4K video to more people than ever before. So staying on the theme of codecs, we also want to mention VVC, which was developed as the successor to HEVC. And the VVC standard was adopted last year in July. And by November, Bitmovin had already implemented VVC in our encoder as an experimental feature. So in early testing, we've seen substantial potential for improving QoE. The graph on the right might be a little tough to read through the webinar, but what we're showing there is that VVC reduced bit rates by 40 to 50% while maintaining equivalent or even slightly better objective quality when compared to HEVC. So just like with AB1, there's still likely to be some more time before the full ecosystem matures, but the upside is that there have been several commercial and open VVC decoders released in the past few months. So companies looking to get ahead of the adoption curve can start building out those proof of concept workflows. And if you're looking for more info on those new decoders and players, check out the software section on the VVC Wikipedia page.
Thank you, Andy. And so talking about adoption, we also asked the video developer community, what is the percentage of where do you use content and where encoding? And while 35.4% is definitely like a good number, we also feel that there's room for it to be applied more broadly. So content and where encoding or per-title encoding, as we call it at Bitmovin, is not a new concept. You can already find research that dates back a few years. But most of the early research concluded that it was effective in test environments, but was not very suitable for like commercial application because it did not work with a fixed bitrate ladder. So this is due to the fact that every piece of content is different. And so each video would require individual analysis as a first step. Now this form of encoding optimization is able to customize the bitrate ladder of each video and based on the complexity of the video file itself. So the ultimate goal is to select a bitrate that provides enough room for the codec to encapsulate enough information to present a perfect viewing experience, but not more than that. So just think about it. It is like optimized like an adaptive package, and it has been reduced down to just the very like the information that yours can actually enjoy. Anything beyond the human's eye's ability to perceive is stripped out. And avoiding unnecessary bitrate profiles will lead to cost savings on storage and delivery cost. But I don't want that you just like take my word for it. So we have here Exhibit A, plugging in a little bit of like shameless promotion here, but this technology and engineering Emmy Award arrived today in our Klagenfurt office, and you see our boss, Reinhard Grandl, holding it proudly. The Academy stated that Bitmovin demonstrated how its use of machine learning and optimization techniques have contributed to the development of massive processing optimized compression technologies. And with that, Andy, do you have like any other numbers and hard facts that illustrate our points?
Yeah, so with per-title optimizations, the potential data savings are obviously going to depend on the complexity of each individual video, but across the board, Bitmovin's per-title encoding is offering significant savings over Apple's standard recommended adaptive bitrate ladder. And so as an example, for a representative medium complexity movie, we see a 59% reduction in storage costs, 39% reduction in streaming costs based on the average bit rate of the complete ABR ladder, a 25% reduction in encoding costs, and 9% reduction in processing time, all due to the removal of unnecessary redundant variants from the ABR ladder.
So, but we also all know that industry leadership and innovation require like a constant support and investment in research and development. So Bitmovin has a strong academic background, and in 2020, we kicked off a joint research project with the University of Klagenfurt called Athena. And head of the Athena is Associate Professor Christian Timmerer. He's also the co-founder of Bitmovin and our CIO. So this joint research project is set to uncover techniques that will enhance the video streaming experience of the future. So resulting findings will be used by the next generation solutions for higher quality video experiences at lower latency, while also reducing storage and distribution costs. So as of today, 48 papers have been published, which you're more than welcome to check out on the Athena website. But we want to highlight here today 2 initiatives that made it into the Bitmovin lab. Shot-based encoding, which is a continuation of the presented per-title encoding, and super resolution, the process of generating high-resolution video frames from the given low-resolution video content. And another reason why we did select these 2 topics is, again, our already quoted video developer report that for the question for which of the following video use cases do you expect to use machine learning or artificial intelligence to improve the video experience for the viewer experience. So right in the top 5 is identifying scene or shot-based boundaries and video quality optimization. And Andy, you have like more details for us going into both of these concepts.
Yeah. So starting with the shot-based encoding, here we have a timeline of everyone's favorite test video, Big Buck Bunny, with every frame represented in the top row. And in the second row, we see the frames where a new shot or scene boundary was detected. Then moving down a row, we've applied Bitmovin's shot-based encoding with bounds on the minimum and maximum segment lengths to ensure a smooth playback experience and compatibility across all devices. And then finally, in the bottom row, we see a more traditional fixed segment length approach with keyframes being inserted in the middle of scenes. And that's a huge waste of bits that could be spent elsewhere to improve the quality. But also by removing those mid-shot keyframes, we can actually have visually smoother playback as we avoid any of the noticeable popping that can happen when a keyframe is inserted. So we see that applying AI and machine learning techniques to improve the shot boundary detection combined with optimizing the segment lengths, we can even further increase the quality gains and data savings from this approach. So then, taking a look at the actual test results from applying Bitmovin per shot to Big Buck Bunny when compared with using fixed 5-second segments, we maintain equivalent quality with a lower bit rate. But that's also just one test asset. And so in doing larger trials with the actual content library from an American cable and satellite TV network, we saw savings of up to 20% when using per-title and shot-based optimization together versus using traditional fixed segment lengths. So next we come to super resolution, and this is a big topic. So I'll give an overview here of what we've been working on, but if you are interested in more detail, you can Google Bitmovin and super resolution. And in the top results, you'll find a great 3-part deep dive blog series from Adi, one of our encoding engineers, as well as a video of a dedicated presentation he did on the subject. So check those out. So first, just a quick primer on digital signal processing. With any digital signal, whether it's audio, video, or something else, it's comprised of discretely sampled data points. So you can downsample a digital signal by removing points, which lowers the amount of data used, but also reduces the quality. Or you can upsample by predicting additional data points and inserting them between the existing data. In the video domain, you can do temporal upsampling if you want to increase the frame rate, or you can do spatial upsampling if you want to increase the frame size or resolution. So there are conventional, more straightforward mathematical equations for upsampling, like bicubic interpolation, or more modern machine learning based algorithms that can be trained and improved. So Bitmovin's focus has been on developing machine learning based super resolution techniques for upsampling content to 4K. So super resolution generally refers to a class of techniques used to upsample video. And essentially, we're taking a set of lower resolution images and feeding them into a mathematical function or machine learning model, which then outputs a predicted high resolution image. And for our investigations, we compared the traditional bicubic upsampling with a few different super resolution machine learning models. So here's a comparison of the outputs. And again, this might be a little difficult to see through the webinar, but if you look closely at the tips of her hair on the right, you'll see that the lines there are sharper. But again, if you're interested in more detail or the exact machine learning models we evaluated, check out Adi's blog posts and you can see these images and more examples in much better detail. So here are the quantified results of that comparison, where we see a VMAF objective quality delta of about 6 between the two approaches, which is a noticeable difference. So we see there's a tangible quality improvement and ROI for this process, and there's even more potential for future improvements.
Sorry, Andy, that I triggered already our conclusion a little bit too fast here. But yeah, this basically brings it to an end, and we just wanted to reiterate like the main points. So UHD formats require more efficient encoding and data compression techniques. The ecosystem seems to be ready for adoption of newer codecs such as AV1 and VVC. And optimizing encoding on a per title basis improves your quality while reducing your TCO. And by applying AI ML models, you can prepare your content for UHD screens. And yeah, like I said, this concludes it. We're also happy to put our contact information into the chat, and if there are questions, happy to answer them. I think you are on mute, Eric.
I knew it would happen sooner or later. The one question we had in the Q&A was someone in the audience is wondering if these slides are available anywhere. And if so, if you could share them. But as you said, if you could put contact information in the chat, they can reach out to you directly for slides or a version of those slides or more information.
Yeah. And I know we also refer to a lot of, we also have like even deeper dives. I know we were here like 20 minutes and we wanted to stick. We don't want to like, mess up your agenda. So there are also like deeper dives into each of these topics available from us.
There's a lot more where that came from, as they say. Thanks so much, Katy and Andy. Appreciate you taking the time today. And our next presenter, we do like to keep things moving along here. Our next presenter is in Berlin, Germany, where it's close to midnight, I believe. And so he pre-recorded his presentation. Oliver Lietz from Nanocosmos is going to talk about how interactivity can build audience engagement. And if you have questions about this presentation, you can go ahead and put them in the Q&A, and I will save them and forward them to Oliver, and he can get back in touch with you directly. So with that, let's roll the Nanocosmos presentation, Mike.
Hello, everybody. My name is Oliver. I'm the CEO and founder from Nanocosmos. We provide an ultra-low latency live streaming platform called Nanostream Cloud. I will share some use cases around interactive live streaming, what that is, and how you can solve technical challenges around this. What all these applications have in common is they are interactive, they are low latency for any audience size in the world with a global scale, browser-based, and can be integrated into custom web applications for B2B branded usage. I will also put the focus a bit on hybrid events. As in the last 2 years, everybody was live online only, mostly from home and no one on stage. Now slowly events are coming back to stage again with physical presence. And the hybrid use case is here to stay, where both physical attendees and online attendees are available at the same time. I see two main scenarios for interactive live streaming where audience engagement is really key. Scenario one is live events. They all have a similar setup. There is a presenter or a group of presenters and an audience which would like to interact with the presenters. The presenters can be either on stage or online or both, which I would call hybrid. This is different to traditional broadcast applications where you are maybe sitting on a couch or in a lean back scenario enjoying and watching a stream. It's more like a lean forward activity where the audience is really doing something, interacting with the presenter group. Some use cases are webcasting, remote presentations, e-learning, which can be in enterprise environments, business environments. It can be panel discussions, political discussions, town hall meetings, or entertainment events like live musics. And all these use cases have several things in common. They are scalable to any audience size. They are accessible on any browser, on any device very easily. The target latency is very low, around 1 second end-to-end, glass-to-glass. And they also have a monetized business case behind it, which require the interactivity and which require low latency live streaming. Scenario number two is a bit different. It's not based on specific larger events for larger audiences. It's more based on a recurring event type of application where you have a revenue channel, recurring revenue channel, monetized content, based on monetized video and business activity behind that. That could be live auctions, live betting, live games, or even live retail where you have a sales channel. And they have similar requirements as the event-based model. It needs to be at a global scale, any audience size, easy to use as well. In these applications, it's more and more used to have mobile-first approach. That means that many or most part of the audience is on mobile and on the browser to directly access the event or the live stream. Needs to be very robust. 100% SLA is the aim to really keep the recurring revenue channel running all the time. But let's first go into more detail about the event use case, because that's very exciting as we are more and more going hybrid. So these cases can be webcasts, conferences, town hall meetings, podium discussions, wherever someone is sharing something on stage or online. So it can be live on stage with people sitting on a venue or on a stage and discussing something, or it can be completely online like we are now in this conference here. Or it can be a mixed setup, so it can be hybrid, a mixture of physical presence and online presence. And the event then is to be shared with a live audience, which can be of any audience size anywhere in the world, which can join the discussion, which can interact, which can ask questions, give any feedback to this session. Let's give an example. A large corporation, 2,000 employees, 5 locations in the world. Everybody in the company is supposed to join and interact with the presenters. So how can this be organized? I can see 2 challenges here. First of all, it needs to be very robust, so you can't lose anybody. Everybody needs to stay connected, have a stable video connection on their device. And number 2, immediate interaction, which means you need to really have low latency and a stable live stream on your device to be able to support this interactive live stream experience. That means ultra low latency around the world in about 1 second. And last but not least, of course, it needs to be easy to use, not only for the audience, which should be able to join on the browser by directly opening their browser and internet access device, but also the production preparation and overhead should be low, so the whole event is able to be prepared cost efficient and easy to use and lightweight somehow. Let's have a look at podium discussion. There's a live situation on stage with several panelists. This event then is sent as a live stream to a global audience. Viewers can join the discussion from anywhere in the world on any device in the browser. They can ask questions and interact with the presenters at any time, and the presenters can directly react to the questions which are asked by the audience. Here you see an example which is done by the additional tool Slido, which is a great tool to sharing questions and give feedback to an audience, to the presenters. Here's another example. It's an expert hearing. So also something like a podium discussion, but somehow the opposite, because no one is on stage here. Everybody is online, somehow in their own home office. It's a virtual meeting, like this conference is now. So this then is shared as a live stream to a global audience. And the great thing is about the user experience here is good because you have everything in the browser. You have the video conference in the browser, you have the interaction in the browser. Everybody can ask questions and directly interact with the presenters. This example here was an expert hearing by the European Parliament group about Google and Apple experts sharing technology behind the COVID-19 tracing app technology. They were using Zoom as a conference tool, which also works very well, which can be combined to a live streaming platform, which then is shared on a web page to interact with the global audience, and the audience then does not need Zoom anymore. What I might find most exciting is some of the hybrid use case, which is a combination of physical presence and online presence. So you have someone on stage or several people on stage, and they are combined by people joining from the online space. So in this case, you see that there is one person on stage and several people joining online. It's a great user experience also for the audience because both the panelists, all the panelists are seen on the screen, and the audience then can additionally interact with the whole presentation setup by sharing that in the browser, adding Q&A sessions, giving feedback, whatever interaction is required for these things. Here you see an example for a full integrated event management platform. This is based on the Open Slides platform, which is an open source platform, but hosted by a commercial provider, which can provide live event management around this. So you have management tools like speaker lists, voting, chat, things like that. And you additionally have the possibility to add live streams and live communication to the system to enable interactive live streaming to large audiences. This is also a good example to see how easy it is to integrate our Nanostream solution into a complex event management platform. The audience can be unlimited, browser-based. We don't care if it's 5,000, 10,000 or more participants. And this is then all branded for B2B applications. Needs to be very stable, robust. High SLA is very important. Integrated into the business environments, accessible on any device. Very important for business applications, privacy and security concerns. So we can comply to GDPR and other regulations. So it can be any important business content like industrial things, steel, construction, legal or medical content. And the focus is really on getting the audio video content transferred in a robust and reliable way, no matter where the audience is located and on which device they are accessing this. Let's now have a look at different use case, live music and live concerts. Live events like these have suffered quite a lot in the pandemic in the last months and years. And the industry is really looking for additional revenue streams and how they can monetize the content and still reach their fans and give a great user experience. That's a great example here as it creates new ways of fan engagement with added value to the live stream. Live performances are not only on stage anymore with live fans, but also sent from home, from bedroom, living room concerts in a small environment and shared with the audience. And how can you create a better user experience and fan experience? With a low latency live stream, the artist can connect to the audience and fans, and they can give feedback directly in form of comments and questions. That's a really good example also for the hybrid use case. The artist directly connects to the fans. They have a video feed. It's a video communication directly between fans and artists. They can be part of the communication, and this whole event is then shared with a large audience which still can be part of the event and also interact with the presenter. So it's a great new setup, which is in this case was hosted by Live Nation, a live concert agency. The performer was on stage in Europe and the fans were located all around the world. It was primarily in North Africa, so it was very difficult to get people directly to the venues and to live concerts in these days. But it was a great benefit and great value for the organizers, for the performers, and also for the fans to have this setup running and with direct connection and fan engagement between the performer and the audience. In a similar setup, fans can also directly text the artist and also buy things, send likes and comments, but do donations, small amounts of money, buy merchandise during the show. And this also enables new ways of monetizing the live video content. I will also shortly touch other ways of monetizing live video content with specific business vertical solutions, which are then having a monetized video channel for every bidder. So that's applications like live auctions, betting and gaming. The remote interaction is already happening for a while already for live auctions. Even in the past, people were dialing in to the agents and to the agency doing bids by telephone, but now that's possible with video interaction. And this can all be done online now. In the left part, you see an example setup which we do with partners in Australia who do high volume and high value sales of real estates directly from mobile phones. So what is needed to create interactive live streaming applications? Let me go a bit into more detail here. You need several things. To make a live content interactive, you need a reliable streaming platform with a global approach, which is fully under your control end to end, and which supports the ultra-low latency live streaming service which you require for your interactive use cases. The basics of an interactive live streaming is this network and additionally the player which is running on all devices. So you open up the browser, you directly see the live stream, and the live stream then connects to the closest location in the cloud on the network which your provider has. This approach needs to be available 24/7, 365, on any time, anywhere in the world. Nanostream Cloud is really unique as a combination of software and services for ultra-low latency live streaming for interactive use cases, because it has the network, the global CDN for ultra-low latency live delivery at any scale, anywhere in the world. It has the player, very lightweight, easy to embed on any web application. Additionally, it has really good tools for getting insight into the quality of service. We provide a metrics and analytics service for that. We have flexible ingest options, so you can connect any camera, any live ingest, live encoding software or service or hardware to the platform. And we have a very unique live transcoding adaptive bitrate control in the player built in, which adjusts automatically to the best possible quality of the network available to any device anywhere in the world, even in hostile network situations. So this combination of software and services makes us really unique. To really get full insight into the quality of service, we created this metrics and analytics platform. So we collect metrics from the players, from our servers, anywhere in the world. So it's good to get an insight onto the quality of service for our support team, but also for you as a customer. Have some business intelligence about the number of viewers, the volume, quality of service in different regions, and also any impact on the quality of service like buffering, which really would kill the user experience, or bad network situations, and so you get a full insight into the QoS and QoE for your live streaming application. The adaptive bitrate player I mentioned automatically adjusts to the right quality available in the network, so we send several renditions out to the network, similar as other adaptive bitrate systems, but optimized for ultra-low latency, and the player automatically connects to the right quality level available in the network on the device you are using or your audience is using. Here you see a test setup running, which I do myself, a real-life setup, where I send a live stream from a mobile phone, and the playback is done in low latency on several devices at the same time. So that really shows the experience with the hand wave gesture of ultra-low latency live streaming. Nanoplayer is really easy to embed and use on your own web page. You just need some lines of JavaScript code which you can copy paste to your web page, and then this live stream runs under your brand on your own web page application. It can even be yet simpler with just one line. You can copy paste an iframe into your web page that can be used for using live streaming within WordPress or any other content management system where you don't need any web development and can just copy a small code snippet into your page. It's really easy to get started. When you use a free live encoder software, you can start live streaming from your own webcam. We support using the OBS, Open Broadcaster software, Open Broadcaster Studio, which is an open source development and which can be downloaded for free. We also sponsor this software. It is running very reliable and also for low latency live streaming. So try it out and try yourself and learn how you can use ultra low live streaming very easily on your own web page. We have several pricing options, very simple pricing based on packages, based on streaming volume, and additional options and support packages are available, so we can guarantee certain SLAs and support activities around your events or 24/7 live streams. Thanks a lot for joining my presentation. Hope to see you soon, and reach out to me if you have any questions.
Terrific. A great walkthrough about interactivity and ultra low latency from Oliver Lietz at Nanocosmos. That was pre-recorded, but you can drop any questions you have in the chat, And in response to a couple questions that are already there, we will ask the speakers if they are okay with us posting PDFs of their presentations along with the videos when those videos are made available on demand. Keeping things moving, next up is John Liu from NETINT. John, welcome.
Hi, Eric.
Hello, thanks for joining us. And
Okay,
you're going to be talking about hardware AV1 encoding benchmarks.
Yes, okay, let me start sharing my screen.
Sounds good. And it looks good. I'll pass it over to you.
All right, thanks, Eric. So good afternoon, everyone. I'm Jian Lo from NETINT Technologies. I'm currently in charge of video fundamental technology R&D in NETINT, mainly focusing on video codec design and algorithm for quality optimizations. So here's a brief overview of our company. Our company was founded in 2015. We actually have a few product lines, but since the very beginning of the time, we have been focusing on next generation SSD controller with onboard video transcoders. We are growing very fast recently. Currently, we have more than 100 engineers worldwide. Most of our team members have quite many years of experience in this industry. And majority of them previously worked for some big companies like Qualcomm, Broadcom, PMC, AMD, etc. We are an international company based in Canada with development offices in China. Our headquarters is located in Vancouver, BC, and we have another office in Toronto. We have a R&D center in Shanghai, and soon our Beijing and Jinan offices will be open. Okay, here's a brief introduction of our recent product. As a hardware video processing solution company, we integrate our purposely built ASIC, what we call Codacity, into solutions that are built for cloud data centers. We have just shipped our new generation of VPUs, where VPU stands for Video Processing Unit. And also we give the name Quadro to it. So here you can see we call it Quadro T1, T2, and T4. Our Quadro comes with a family of ASIC-based video transcoders packaged in U.2 NVMe and PCIe AIC form factor. The unique solution is designed so that our customers, mainly on the cloud side, those video operators, they can easily upgrade their x86 or ARM-based data center servers to hardware-based video encoding servers. So regarding the encoding format support, we are able to encode H.264 AVC, H.265 HEVC, and AV1. Meanwhile, we also have embedded decoders. For the decoding capabilities, we added VP9 decoders, where we believe there's a use case for that. The highest resolution we could support for a single chip is 8K and 60 IPS real-time encoding. So in a short word, by using our Quadro solution, we could offer a 10x density improvement over the software encoders and a 20x reduction in energy consumption as compared to CPU-based workflows. It could reduce the operational cost by as much as 40x and the carbon emission by 80x. Okay, so this is our on the inside the red box. This is our Quadro T1 shipped in U.2 form factor, and the Quadro. Then we have a Quadro T2, which doubles the capabilities of encoding, and the T2. So therefore, the T2 is capable of encoding 8 live, 4K 60 IPS 10-bit AV1 streams at broadcast quality. Again, we could double the capability again with our T4, which has 4 code-density G5 ASICs inside. But regarding the video quality, the quality will not be changed. And we'll talk about the video quality later. Meanwhile, I also need to mention, like, we support, Dolby Vision, also have hardware acceleration for video intelligence, data mining, and other machine learning and AI applications and services, because we have a powerful AI inference engine, also a CPU, a DSP processor, or other hardware chips inside our Quadro. So the addition of 2 deep neural networks engines, each is capable of 18 trillion operations per second. Okay, here's a block diagram for our VPU workflow. Right now, I'm going to use our Quadro as an example. This figure, so on the left side of this figure, we can see that the videos could be generated and transmitted lively through the internet, then decoded using our hardware decoder. And inside this red box, it's actually our host server. And with the decoded YOV, because we have a embedded CPU and AI engine, we can do some basic additions on top of this YOVs, like we can do text overlay, timestamp, add replacement, and insertion. Also, we could do even more advanced processing, for example, like identify the region of interest, face recognition, motion detection. We could use for privacy masking, deep learning video analytics, and event generation, the event and alarm triggers. Of course, these are just a few examples about what we can do using our CPUs and AI engine. We could definitely do more with these hardware capabilities. So, of course, the main focus will still be our video transcoding. So with the previous video processing or without it, we can re-encode the decoded videos by our video encoding engine, and we could using encoding ladder output, which could fit for different frame rate, resolution, bitrate quality, which might be suitable for different viewing devices like TVs, phones, or different network conditions. So we know that H.264 and H.265 has been on the market for many years already. There have been appeared multiple solutions based on different hardware chips, which could do H.264 and H.265 cloud transcoding in a reasonably good qualities. Well, talking about AV1, so we think AV1, we always consider AV1 as a royalty-free codec, which is more efficient than other existing standard-based codecs. The potential of AV1 to bring a tangible benefit for various video-related apps or services is becoming real. Even though the AV1 standard has been finalized for a few years already, and we have witnessed quite a few software-based encoder, either on the cloud or client side, serving for various applications. Matt Frost from Google mentioned before, compression efficiency comes at a cost of computing. The AV1 ecosystem will soon benefit from having an ASIC-based hardware encoding solution available for the data center. So the product we just shipped is the world's first AV1 hardware encoder. So today I'm going to share with you on our AV1 hardware encoder design, performance, and quality. So we believe the AV1 hardware encoder should and could be used for a wide range of applications, including video on demand, video live broadcasting, video conference, VR, AR, cloud gaming, and even possibly other emerging applications. And these videos, these applications will need different video quality range. We have a different latency requirement. But if we do want to have add a limit to the current applications or the future applications, I would say these applications do need to have high speed, high quality video compression. That's why for our video quality compression, we're trying to cover a wide range of HD and UHD video content to be compressed. So for the text sequences wise, we have selected more than 20 sequences, 4K 60 IPS, 4K 30 IPS, and 1080p 60 IPS. Some examples are on the images are on the right side, and we also trying to select some gaming content besides the PCG content, and some are from the standard test sequences. Different videos will have the different characteristics, like fast motion, slow motion, global pan, zoom in and zoom out. This will try the best effort to validate how good or even how bad maybe for the AV1 encoders, different encoders. Meanwhile, as I mentioned before, we always define our video quality to be a broadcast quality. Well, this kind of definition is somewhat vague. So think about when we are trying to view HD, UHD videos, we would like to have a video quality without noticeable artifacts. This is probably a simpler definition of what is broadcast quality. So that will be our video encoder main operational points. So even though we have tested ultra low bitrate, low quality, or ultra high bitrate with visually lossless video qualities, but this time we would like to focus on those broadcasting level video quality. We have been using PSNR, SSR, and VMAF. All these three indices are showing the same trend. For comparison, we select SVT-AV1, the software, open source software encoder, which has been widely used. Version is 0.8.6, which should be the latest one. And we use different presets. The larger the number, the faster the speed, but the lower the quality. We selected preset 864. And we use the Intel Xeon CPU. It's a 2699V4. It has 22 physical cores at which each core the CPU is about 2.2 gigahertz. We also insert our our hardware encoders do not need such a powerful CPU settings, but we are trying to use our hardware encoders configurations to be aligned with SVT-AV1 to be fair compression. Bit range will be like 8 megabits per second to 120 megabits per second for 4K 60, and for 4K 30 we reduce the bit rate, and you even reduce more for 1080p. But this should be able to cover most of the use cases. Okay, so first let's look at the performance. Let's take a look. As I just mentioned, if we want to get a good quality, we have to use preset 4, but which is slower. So with our 22 powerful Intel cores, we can only achieve 0.3 IPS for 4K 60 encoding, and roughly like 1 IPS for 1080p. Of course, with the faster the speed, with the higher the number of the preset, but the quality will drop, and we're going to take a look at the quality in the later slides. And also, these numbers is like it's like 0.341, and we just pick a one sequence for that because for hardware encoders, they use a lot of fast algorithm, And actually, we do see the encoding speed fluctuate a lot for different sequences and even different shots. Well, if we put 10 of our Quadro T1 VPUs on top of Dell servers, we could achieve, for 1080p, we could achieve almost 10K IPS, and 4K, for 4K, it's about a quarter of that. It's we could achieve 2,400 IPS, and these encoding speed will always remain as a constant. Okay, now it's time to talk about the BD rate. We use VMAF, which we believe will be closer to the human visual qualities. So look at these different curves. On the top of these curves will be our Quadro AD1. And then we have different curves for different presets. As I mentioned before, the higher the speed, the lower the quality. In average, we could achieve 24% bit rate saving compared with SVT AV1 preset 8, roughly 15% over preset 6, and 6.7% over preset 4. And the maximum gain is about more than 50%. Okay, now here, let's take a look at the visual quality. Yeah, we prove that, we show that VMAF, on VMAF indexes, we are better. And now, so for this is a screenshot from SVT AV1 for 4K video. And then we take a look of this one for our Quadro. It may be slightly difficult for viewing in this webinar, but if we are going back and forth over these two screenshots, it can be easily seen that a lot of details are washed out. More obvious region is those electric poles on the bridge. Almost everything is washed out for SVT AV1, but we still keep all the details for using our Quadro AV1. Okay, another example is for using another gaming content, Witcher 3. It's encoded as 1080p 60 IPS. Yeah, so again, the savings will be, the savings numbers will be the same as before, because our average is doing across the 4K and the 1080p sequences. And for this specific sequences, roughly we can achieve more than 20% of the gain. And the VMAF number ranges from 75 to 96, 98, which covers which is a good coverage of most operation points human beings would like to view the video content. Okay, here's another example using for a screenshot. This is the SVT AV1 screenshot, and this is our Quadro numbers. This is quite obvious if we probably we don't even have to go back and forth. Just see like the details are gone, and I probably will not call this as a broadcast quality for SVT because it's hard to tell what are those objects are. And here, like we see a lot of details about those grasses and the objects. Okay, so thanks everybody. So we have completed our first round of bringing up our Quadro hardware with some quality optimization algorithms, which include rate control, look ahead, AQ mode, etc. But we do believe there's still plenty of room for future improvement. Since the product we are going to ship is a video hardware solution based on our VPU, we are not limited ourselves to be, just the video encoding use our video transcoder. For the video encoding side, we still have not fully utilized our hardware for capabilities, enabling the functionalities like object detection, classifications, segmentations, ROIs, per scene, per shot encoding, or like, even content adaptive rate control, something like that. There could be a lot to be done using the whole hardware solution. And also, we don't think hardware and the software encoders are totally different. Starting from our design period, we designed our hardware encoder considering a lot of techniques from the software encoders. While some of them might be a good fit, and some of them might need to be modified a lot. Again, but we do believe our hardware encoders have a lot of room to be improved. Okay, thank you for taking the time to listen to our presentation. We would like to give you a closer look at what our products can do in our video operations. Feel free to visit our website or send an email to info@netint.ca. Thank you.
Thank you very much, Jen. And there were a couple of questions in the Q&A, but Mark Donegan, who works with Jen, addressed those. That email address is in the chat if people just want to click on it and send an email. Thanks to all of our presenters for this innovation hour. It's the end of the day. I'm getting a little loopy, folks. NETINT, Bitmovin, and Nanocosmos. Thanks for joining us. Thanks to all of our sponsors. And the Amazon gift card winner is Takahiro Karasawa. So Takahiro, watch your email for information about that. We'll be back at 10 a.m. tomorrow to talk about AV1, actually, with an all-star panel featuring speakers from Twitch, Netflix, Facebook, Google, and Amazon Chime. So we hope to see you then. Thanks again, everybody.
VideoGuys.com is your source for the LiveU Solo, and our Black Friday special starts now.
Stream from anywhere, anytime with the LiveU Solo and Solo Connect bundle. Buy now with the 2 or 3 modem kit and get 1 month Solo Connect free. This includes unlimited data and LRT Cloud and is only available until November 30th, 2021.
Go to VideoGuys.com or call us at 800-323-2325 to take advantage of LiveU's Black Friday special today.
In this era of streaming video, we are pioneers, helping make your stories more vibrant. Conviva lives in billions of apps on devices all over the world, measuring trillions of data points each day to provide real-time insights for your content, ads, and social. Conviva. Every stream, every screen, every second.